Hello, hello. So we are now on.
No
Everyone
suena
is not
Cristo.
muted. Oh. All right, let's start for real this time. So welcome to, we're now on week 3 of our backend section of full stack web development. So we're now moving away from the API layer down to the database. And the database section is going to be a little weird because of Christmas. So we will do half of it this week, and then we'll spend 3-4 weeks on break, and then we will come back to it. So this week will be week 1 of data persistence and databases. So far the database has been an important part of what you've seen with the backend, but it's been basically out of sight, out of mind. But now we get to look deeper and see what's actually going on there. So tonight we're going to talk, we're going to set the stage for the database stuff. We're going to kind of talk about what is a database, what is a relational database, and learn some of the basics of SQL. Tomorrow we'll look more deeply into how we actually plug it into our web app, or not tomorrow, Thursday. We will look more deeply at how we actually plug it into our applications. So we'll learn how to write the kind of code that's been in our database files in these repos that we've been using. So before we get started on any of the coding, I kind of want to just talk about data persistence and databases and what it is and why it's important. So there's this term, data persistence. What does that mean? Well, it basically means that you need some sort of data that persists, that it's available from moment to moment or day to day when you use different applications or websites. So let's think about a couple examples of apps that would not need a database, would not need data persistence, and ones that do. I'll say right now that almost every app in this day and age falls into the latter category, which is why this is a really important topic. But let's start by looking at some simple examples of things that don't require a database. So one example that I really like is the idea of a calculator. A calculator is a useful tool. You go, you pull it up, you can do all sorts of crazy stuff with it. But when you pull out a calculator app tomorrow, it's probably not going to know what you were working on yesterday. So it's a blank slate every time you use it. And for a simple calculator app, that would be perfectly fine. Another example of a website that wouldn't have data persistence would be a simple website for a business. So you just kind of your standard, it has the hours, it has a little bit of info, maybe a map, but that's it. Every time you go to that site, it's basically the same. It doesn't need to store anything from you or from anyone else. But many sites and many apps do require data persistence. So if you now move into the territory of a business that has an online store, now you need to be able to log in and you need to be able to keep track of items and store them in your cart. That all needs to be kept track of in a database, both in terms of your own login info, but also in terms of just the items that are available and things like that. And so it turns out that most of the tools we use do require databases. So important thing for us to learn. And it turns out that we need more tools in our tool belt than JavaScript. JavaScript is a pretty amazing, powerful thing, but we're now moving a little bit out of the JavaScript territory and into SQL land. So before we talk about SQL too much, though, I just want to explore the idea of what is a database. And a database is, there's lots of things we use in life that use kind of this database model. So I'm going to actually go ahead and share my screen. And over here, I have pulled up Numbers. It's like Max Excel knockoff version. And an application like Numbers or Excel is something that we're maybe a little more used to. It's kind of like a simple version of what a database does. So let's just start there so we can start to get an idea of these concepts that we're going to be working with in this section. All right. Okay, cool. So up here I have just a couple, I was just putting this together right before class, so it doesn't have very much stuff in it. But you guys were working on for your homework a little app or the back end of an app that has to do with users and posts, a little blogging thing. So imagine that you were trying to keep track of these users. Well, a good place to start might be creating a table of some sort. And Excel or Numbers is a great tool to do that. We will see shortly why it is also a very limited tool to do something like that. But you could say, okay, I'm gonna have to keep track of my users. So I know I need some place where I can store all my different users. So that's what we call a table. We call it a table in database world and in Excel world. And then you might say, okay, well, let's create some column headers. What are the types of things that these users might have? Well, we know they're gonna have a username, maybe a phone number, an email, a first name, some other random stuff like that. So by defining, okay, we know we're gonna have a collection of users and we know each user is gonna have these different fields. Now we've set up this schema, this template for creating users, and we can just enter them on in our Excel spreadsheet. And then we might say, okay, wait, but there are also posts. I know that my users are gonna be making posts, so let's create a new table for that. And this one's a little simpler. We need to know the date, probably the date and time it was made, whatever text was in their post, and then we need some way of knowing, maybe this is a username, that will help us link up which user made this post. And I haven't put anything in here, but we could imagine putting some data in here. So this is cool. We have a nice way of keeping track of our users and their posts. And I'm sure some of you guys can already see the limitations on this. And anyone who is familiar with actually creating database tables in SQL knows that this is a pretty primitive thing. So let me give you an example of some things that we cannot do very easily with Excel that we will, by the end of tonight, know how to do with SQL. So some limitations are, what if we wanted to put some restrictions on these? Like we wanted to make sure, let's say the email is required. We wanted to make sure that there was an email field. There's no way to really require that in Excel. You could just leave it blank. What if we wanted to make sure that there were no duplicates in username? There's nothing to stop me from just copying and pasting this and putting a bunch of duplicates in here. Once I have my posts in here, wouldn't it be nice if there was a way to more definitively link the user that created this to the post, apart from just copying and pasting over their username? Those are all really things that would be really nice to do while keeping track of this data. And that's just, in terms of setup, but what about if we had, this is a very small list, but if we had a list of 100,000 users and I wanted to find someone really easily, I could do I could do Command F, but what if I wanted to find them in a sophisticated way? I, wanted to find all posts from a certain date by a certain user, or all posts in a certain date range, all by Jimmy. Well, now Excel is starting to seem like a pretty crappy tool for that. There's really no way to do that apart from using the find feature and searching through and trying to dig it out. And those types of complex queries are exactly the kind of thing that we as developers need to do all the time. So we can look at something like Excel as a good model for how to start with SQL, but we'll find out pretty quickly that there's lots of things that we wish we could do that we need a more advanced tool to do. And that's why it's important that we have a language dedicated to storing and finding and updating data. Cool. All right, and I'm sure Excel is a dark, dark pit of wonderfulness and horribleness. So I'm sure there are some ways to do these things in Excel, but it would probably be a total pain. So let's not do that. Yes, super tedious, sums it up nicely. Okay, so now we've used maybe a more relatable model to explore some of these ideas in terms, but let's go ahead and get rid of Excel. We don't like Excel. Let's use SQL from here on out. So relational databases. So a database is really just a way of storing data, and there are different types of databases. We're interested in relational databases. It is one of multiple types of databases. There are also things like document databases, Mongo, for example, or graph databases. I personally haven't really played with graph databases much yet, but they look like a lot of fun. So I've been meaning to do that. Document databases, I think, kind of suck. I know that there are some use cases where a relational database isn't necessary, but relational databases are so much better. And that is totally my own personal bias, but there are also reasons for that. Relational databases have been around for a really long time. My dad was a programmer back in the 90s. And when I started programming, it was like, the languages he used back in his day and the languages I used were totally different, except SQL. Like, he was using SQL back in the 90s. I'm still using SQL today. It's just like, it hasn't grown old because it's just that good. The other reason from a practical standpoint that it's good to know relational databases and SQL is it's a very in-demand job skill. That's actually, at Lambda, we used to not even teach it, but so many of our hiring partners requested it that we're like, hey, we should probably teach this. Yes, SQL, just like C, SQL will not die. So what is a relational database? Well, that's one of those things that's a little hard to answer until we actually get into it, but it has to do with the way that related data is connected to each other. So we'll actually not really even explore this in much detail until after the break. So you'll have to kind of go on faith that relational databases are a thing. And we'll be able to talk more about what that exactly means once we're able to explore things like foreign keys and the relations that actually exist. But to sum it up, it's basically the system of, just like we did in Excel, of you create tables, you define what your tables look like, and then you fill them with stuff, and then you're able to very easily look at that data, delete that data, update that data, combine that data in interesting ways. It's a way of keeping track of data, as you might have guessed. That's what we're doing. All right, so, and as far as this which type of database is better thing, I do have to say it depends on the problem. It depends on what you're trying to model. There might be an app or a situation where a document database is just makes more sense and you're creating extra work for yourself by using a relational database. It's just pretty hard to find a system that can't be modeled decently well with a relational database. So it's very versatile. Okay, so moving on, let's talk about SQL. So SQL or SQL, I think it's technically supposed to be called SQL, but everyone calls it SQL, is the structured query language. So it is the language of databases. So it's very different from JavaScript or Python or any of these programming languages, because JavaScript is meant to be extremely versatile, right? You can do just about any problem you could think of, you can do with JavaScript. It's extremely open-ended. SQL pretty much just works for querying data. It's a very specific language. It has a specific use case, which is querying, updating, and managing data. So that is the actual language that we will be using. To access these databases. However, as I'll talk about a little bit later, we can kind of use JavaScript to mock out SQL, and that's pretty common. So I know I said I was getting rid of the spreadsheet, but let me bring it back real quick. So think about this problem I brought up earlier of, if I said, okay, I would like to find every post from December 1st to December 4th posted by user Jimmy654. That type of request is the sort of thing you would write with SQL. Or if you say, I was like, okay, I would like to insert an entry into posts with this date and this text and this username. That's the type of command you would write in SQL. And as we'll find out soon, SQL is actually, until you get into the really crazy stuff, SQL is actually a very readable language because it is these requests. I would like to add this to the database. I would like to read this from the database, etc. All right, now we're getting rid of this. So let's look at some SQL samples super quick. Wow, that was very alliterative. SQL samples super quick, super sly. So I'm going to show you some quick SQL samples, but then we're going to talk more about theory and high-level stuff and how to get a database on your computer and how to play with it and all that stuff. But at the end of the lecture, actually for a decent chunk at the end of the lecture, we will just focus on actual writing of SQL. So don't panic if I go through this quickly. I just show you the kind of things that are possible. So as I said, by the way, I'm just in this SQL Try It editor in W3 Schools. We will be back here later in the lecture, and you guys will get to play with it in the homework tonight. So they have this pre-populated database that we get to play with. Right now, I'm messing with a table called products. So this is kind of an online marketplace type thing. Let's say that I wanted to select all the products. The star just means all. So as I said, SQL is very readable. This just says select everything from products. And when I run it, I get a gigantic list of every single product. As we can see, there are a bunch of different suppliers. So I could even say, okay, well, I don't just want all the products. I want all the products where the supplier ID is 2. I only care about this one supplier. So I could find it. If it gets more complicated, I could say, okay, what about all the products where the supplier is this guy and the price is in a certain range? I could just keep going and going. So this is a little bit of an idea of how you can use the SQL language to actually query data. We'll also be using it briefly to update data and add data and things like that. But that's really the idea, is we're making more or less specific requests from our database using this awesome language called SQL. So we will come back to this in a little bit. What do I want to talk about next? Okay, so the next thing I want to talk about is this question of what do developers really do when it comes to database stuff? And I actually am going to bust out the old Node Mini Express that we've been playing with the last few weeks, just to show you a few examples. So databases are definitely going to be part of your life as a developer, particularly a back-end developer. But the people who really deal with the databases are usually database administrators. That's a different job. So there's a balance here where you guys don't need to become database experts, but you do need to know enough about databases to be able to do your job and be able to communicate with the database people. So I wanted to just start by exploring what do developers really do. And it turns out that a lot of what developers do actually isn't necessarily writing SQL. So there are a lot of libraries that mock out SQL in JavaScript. And it turns out that this code you've been using actually uses one of these libraries called Connects, which we will explore on Thursday. So it turns out that you can write sort of pseudo SQL using JavaScript. And we can even see, this is basically let me find, so it turns out that this right here, this bit of JavaScript is actually saying, select all from users. And this is saying, select all from users where the ID is equal to an ID, right? We're used to using these methods, find and find by ID, but now we're starting to see how what's in them relates to this database stuff. And then this is saying just return the first one. So it turns out that you don't actually always need to know SQL to do SQL queries, because there are these tools like Connects that allow you to do that in JavaScript. So this may be kind of a weird thing for me to say at the beginning of this section, because it almost sounds like I'm saying, well, we're going to learn this, but you don't actually need it. I want to dispel that right now. There are some jobs where you may not have to write any raw SQL. But there are also a lot of jobs where you do. When this library, if you're trying to do something complex enough, this library might break down and you'd want to use a raw feature on it. There are also, in my experience, sometimes in debugging, it makes sense to actually poke around in the database so you can see what's going on in there versus in your code. If you actually have to dig in the database, you need to be able to write SQL. But even if you're not writing any SQL, you still need to know SQL, or at least you need to be proficient in it. And the first reason is that in order to understand how a library like Connects works, in order to really understand it, you should probably understand the language it's built on. So you will be flailing with Connects. You will never be able to use Connects really well unless you actually understand the SQL behind it. Another reason to understand SQL is that you want to be able to communicate with your database people. If you're not dealing directly with the database, someone is, and you two need to be able to talk about things and be on the same page. And if you understand the tools they're using, you're going to be able to communicate a lot better. The final reason that I think it matters, or maybe an incentive to really learn this stuff, is actually I have a couple more reasons. One is that your API and your database models, when I say database models, I mean this code. These things are going to, if you understand how SQL actually works, you'll be able to design them in a way that makes life easy. If you don't understand how the database works really and how querying works, you might set up your API in a way where you're actually fighting against the current. SQL is definitely one of those languages where if you're trying to do something that isn't really what SQL is designed to do, it can be a nightmare. But if you're working with the grain, some very complicated requests can actually be stuff that would take 50 lines of code in JavaScript, can just be one SQL query. So understanding SQL will help save you time and effort. And the final thing is it's going to be a skill that sets you apart. I do know a lot of developers who have pretty weak SQL skills. Everyone knows how to do a basic update and a basic select and a where statement. But if you actually understand this stuff, like that makes you valuable. That really makes you valuable because a lot of developers slack on this. So that's kind of an invitation to you guys. If you want to really set yourself apart as a developer, there are many ways to do it. This is definitely one of them. All right. So there's a little bit about what we actually do and don't do as developers with the database. Oh, and I see a couple questions popping up. Let me address those before I move on. I see that Luis has asked, will database developers be the ones in charge of just building and getting everything secure while we do the queries in our Node app? Yes, and I'm actually going to talk more about that later, but that's a good basic way to think about it. Do you have to use Connects or some other library? Can you make a SQL query within vanilla JavaScript? You have to, there has to be some way for SQL to meet JavaScript. I don't know if there's anything built. To my knowledge, there's not anything built into the language that would let you do that. There might be some convoluted way of doing it. But what I have seen is that sometimes you see something like this where there's no SQL on this page. This is all JavaScript. But sometimes I've seen apps where, because on these libraries, there's always a raw feature. Sometimes you see code bases where there is SQL actually written in, but they're still using a tool like Connects to actually parse it and to actually make the connection to the database. So there is this scale of how abstracted the SQL is, but to my knowledge, there's really no good, fast way to connect to the database. And there might not be any way to connect to the database. Well, there has to be some way because these libraries are built on something. But the best ways to connect to the database that I know of are just using a library that's already has all of that set up for you. Can I or another faculty show how to do a mini track that helps us get the SQL edge? Interesting. I haven't thought through that. I'm gonna have that be something I sit on so that maybe when we're done with this, or possibly just tomorrow going into the break, I can give you guys some ideas of how you might go a little further with SQL. That's a good question though. One that I just haven't thought through. A brown bag. I've never done a brown bag. I would be probably really interested in doing a brown bag on SQL. So I'll look into that. by the way, I am a huge database geek, if you guys haven't figured this out already. I think if I ever go back into the full-time industry world, I probably will head more in the direction of database administrator than developer, because this is some of my favorite stuff. So for me, it's like, oh, why wouldn't anyone learn this? This is just fun, but I'm a complete dork, so I understand that some people don't like this stuff. All right, cool. So let's, what do I want to talk about next? I see more people typing. I'll answer some more questions as they filter in. But first, I want to tell you guys a little story about when I was in a coding immersive. I had just gotten back from Thanksgiving break, so it was kind of this time of year. I'd just gotten back from Thanksgiving break. My computer had crashed over break. So I was trying to get all my environment stuff set up, and I was way behind because I was trying to work with this new computer. It was super stressful, and I was trying to get Postgres. We'll talk a little more about Postgres in a minute. I was trying to get Postgres set up on my computer. And I had this like existential meltdown where I was like, but what is a database? And the people in my group, we were just in a group project time. It was an in-person thing. So we were all sitting around these tables in this co-working space. And everyone in my group is like, what are you talking about, Diandra? A database is where you store stuff. You know, it's the thing you query. It's like, but what is it? Like, where is it on my computer? What does it look like? I don't understand. And no one could answer this question for me. And they're like, does it matter? Just follow the instructions and get it set up. And I'm like, no, but I can't. What is a database really? So, and I think I was mostly just stressed out because of the new computer and computer crash stuff. Nothing sucks more than having your computer crash when you've like just quit your job and decided to dedicate several months to something that you really hope will get you a better job, but you really don't know for sure. And then, yes, and then I spiraled into a whole what is the meaning of life thing. But I wanted to, prevent this trap from any of you people who maybe are as crazy as I am out there, and talk about this, what is a database thing. So it slightly depends on what database you're using, but for starters, a database is just a file that lives on your computer, or, you know, a server theoretically, but it's just a file on your computer. And I can even point at the file, in this case at least. Lambda.SQLite3. This is a database file. If I click on it, it tells me I don't want to display this. Yikes, should have listened to the warning message. So it's not a file that's meant to be opened in a text editor. It's not a file that's meant to be, it's not like a piece of JavaScript. It's not meant to be opened and looked at and edited. But in this file is actually stored in something more deeper than my knowledge, is all the stuff in the database. All the entries are stored in this file. So a database is just a collection of data in some way. But then there's this question of, how do you access it, right? We know you can't just open it up and you can't just open it up and play with it directly. So how do you get access to the database? How do you communicate with it? And this leads into the next important topic, which is that there are tools called database management systems, or DBMSs. We're specifically interested in a class of these called RDBMSs, which are relational database management systems. So I know that's a mouthful, but these DBMSs are just tools, just pieces of software that we use to actually access our database. And so one example is SQLite, which is what we'll be playing with today. So SQLite is not a database itself, it's a tool that lets you access your database or create your database. It is like the ambassador between you and your database. And because databases are such abstract things, we always need one of those. So I mentioned Postgres. Postgres is my personal favorite of these database management systems. And this was part of my crisis, is being confused about what is Postgres. Is Postgres the database? How does it play into this? Well, something like Postgres or SQLite is the tool that lets you communicate with your database. So I really like Postgres. It's a little more of an advanced tool. We might be switching over the curriculum to using it, but for you guys, we're still on SQLite. SQLite it's a good learning tool because it helps you get off the ground. There isn't crazy installation. So probably less likely that you guys will have an existential crisis with this because SQLite's pretty easy to get off the ground. So this kind of answers a question that I just saw pop up, which is SQLite SQL? No, different. And you can have a file that has the extension SQL, and that's just raw SQL code. That's something you can open and edit and is totally friendly. But something with the SQLite 3 extension is an actual database, because SQLite is a tool that we use to communicate with our database. So what kind of things do these tools make available? Well, I'm actually new to SQLite too, so we'll be exploring this together. But with Postgres, to give you some ideas, there's command line commands built into it that you can use to do database related things. On Mac, there's an app that you can use to talk to your database. And then there's also a little REPL type thing where you can actually go into the database and type in raw SQL queries and get access to it. So these database management systems let you do things like that. There'll also be an intermediary when you hook your code up to the database, which we'll explore on Thursday. So I don't want to talk about that one too much. So let's switch over to talking about SQLite, because that's what we want to use today. And yes, someone just mentioned MySQL. That's just another one of these database management systems. So you guys were all asked to get a tool called Well, you were all asked to first install SQLite. If anyone has not, I should have pulled this up, but just install SQLite. I was just here today. Oops. I don't know where no, there we go. There's their website. I feel like I was at a much better page than this earlier. All right, well, I see people are already posting links. Awesome. Maybe you don't have to install SQLite. I think it might already be there. I'm trying to remember. I did this today. I should remember. I think you just have to do DB browser and you're actually fine. Or SQLite 3 specifically. Oh, well. Clearly, I've come to class unprepared. I apologize. We'll work it out together. All right, so I'm outsourcing this to you guys. Find the links and post them. So we want to make sure we have SQLite. We also want to make sure that we have this DB browser for SQLite. This is what will help us do the things. I'm pretty sure this is the only thing I downloaded today. And I think that's all I was able to use it. So I think that's all I need. But I might be wrong about that. We will find out. What does it say in the syllabus? Syllabus knows best. Here's the SQLite official site. Okay, we just need the DB browser. Cool. So this thing, let's try to find a good link for this. Yes, this is where I was. All right, posting this link on Slack. So let's make sure that we get this guy installed. Or with Homebrew. Thank you for posting that Homebrew link, or command, not link. So I will give you guys a couple minutes to get that going and answer any questions in the meantime. How deep will we get into SQL? Medium. I mean, we won't be talking about any, to be perfectly honest, I haven't fully prepped my week 2 stuff. And by fully prepped, I mean, I've almost entirely not prepped my stuff for after the break because I figured I would do that during the break. So I don't 100% know the answer to that. I know we're not going to be doing really the DB admin type stuff, which is like permissions and stuff like that. We'll definitely be talking about foreign keys and joins and things like that. But the emphasis is going to be more on the developer side of it. So looking at how SQL relates to servers and how to connect those with models and using tools like Connects. I don't think we'll be doing any pivot tables. Next question, is my PHP admin from WordPress similar to any of these database things? I have no idea because I have never really worked with PHP or WordPress. But if anyone has and also has any knowledge on SQL, please let me know. All right, I'm just about to put out a poll to see how you guys are doing with getting this up and running. As far as installing MySQL with Homebrew, I don't know. I've used MySQL like once or twice, but it was a while ago. So I do not know that one. I will say this is one of the many lessons I learned on the day of my existential database crisis, which is if you are trying to install Postgres, you can do it via Homebrew or you can do it via the Mac app. But if you try to do both, terrible things will happen. So if you're on a Mac, pick one or the other. All right, I think almost everyone has this up and running, so I'm going to go ahead and move on. And for those of you who are still getting it up, I apologize, but train's got to keep going. Sorry. All right, so the first step when we want to, so this is another one of those clarifications with databases, is what we have here. This thing isn't a database. This thing is a tool for creating and accessing databases. And it turns out, yes, we can have multiple databases. If we were working with different projects, we would absolutely want different databases for different projects. Sometimes the same project will have multiple databases. One example I can just give you from my own work experience is I was working on a data project where we dealt with sensitive medical data. So there's, personal information. And we had to be very careful with this. So we had our real database. It was behind a bunch of different security things. And then we had just this test database that was accessible to everyone on the team from everywhere. And they were set up the same. They had the exact same schema, which you will learn shortly what a schema is. But they were completely separate databases that didn't touch each other because one was something that should be easily publicly available and one was something that was heavily, heavily guarded. So the first thing we need to do when we want to work with the database is we have to create that database. So before we move on, what should we create? What's a possible app idea or project idea that we can very primitively mock out here? I would like some suggestions from the crowd. Always open to absurd ideas. I actually slightly prefer absurd ideas. But if no absurd ideas appear, we will do a coffee shop. Ha ha ha. what I do the rest of my time. Crayons. Interesting. I'm trying to think of, let's do art. So I think crayons might be a little tough, but let's do art supplies. Or maybe just, actually, I like crayons. Let's work with crayons. Very interesting idea. So, okay. Maybe we'll make it art supplies, but we'll create a crayon table on it. So in this DB browser tool, let's start with new database. So I'm going to save this as art supplies. Cool, and it's already trying to get me to create a table. So, so yes, now we have one database. And one thing to keep track of right now, because this tool is nice and easy to use, we know that we're creating a table in the right database. But if you're using something a little more advanced, like Postgres's command line tool, you'd want to make sure that your table was going into the right database. But I think we can be pretty confident that this will go into our database. So let's name our table crayons. So each table is, it encapsulates something we need to keep track of, something we need to store. So this relates to this idea of a resource. And this idea of a resource is something I brought up on day one, and I've kind of been hinting at since then. And I said that we want to model our APIs, our endpoints, based on resources. And one of the reasons we want to do that is so there's this clear flow between our endpoints and the database. So when you think about these resources we've worked with, like users or posts, or I can't remember anything else we've worked with, each of those would have a database table that maps to it. And that's not to say that every resource will absolutely have a table or that every table should have an endpoint. But there is this relationship between the two. So we can imagine, thinking about the stuff we've been doing the last 2 weeks, that if we were creating a full back end for this art supply thing, that there would be an endpoint, a get endpoint for crayons, and there would be a post endpoint for crayons, and an update and delete. And we'll keep talking about that and how these CRUD operations relate to what we're doing with databases. But I'm getting ahead of myself. So we have a table. And when we're creating a table, we have to create a schema. So a schema is all about what should the table look like. If we bust open our this Excel sheet again, it's kind of like these columns, you know, we're thinking, and in the case of SQL, we'll call these fields. What fields should a crayon say? What information about each crayon we put in here do we need to know? So once again, opening up the floor, what do we need to know about each crayon that goes in here? Color, brand, taste. Melting points, size. So one thing that I'm curious about is how much of the crayon is left. Percent used, exactly. Cool, so we could add all these fields in here. So we probably want name. And then type, that's gonna be text. Let's add another field, color. This could be stored in different ways, right? Like we could have a color that we just say a color name. We could also, as suggested, have instead a red, green, and blue value. They're all stored as integers. We could have percentage used. That would be a real number because we need to store that as a decimal. We could have melting point. Cool. That probably also, let's do that as a real number because we might need decimals on that. This is getting all squished. Okay, so cool. So I think we have some idea of stuff about our crayons. I'm not going to do the brand or manufacturer because I kind of want to explore something else with that. I do want to do this idea of box ID. I don't know. Let's not explore that yet. That gets complicated. How do I get rid of this field? Oh, with remove field. Okay, so let's talk about some of these other things. So when we're creating these fields, when we're creating a schema, there's all this cool stuff we can do to make sure that, that what's going in this table looks the way we want it to look. So we already saw type. And type is going to depend on what tool you're using, but it's kind of, you'll see the usual cast of characters. There's going to be text. It's often called varchar. Integers, real numbers, so decimals. Blob is, we don't have to talk about blob. I don't know the difference between numeric and real. You guys are welcome to Google it and find out for me if you want. But beyond type, there's these other cool constraints we can put in. So this is not null. Name needs to be required. Actually, I'm going to say all these are required except melting point. If we know or I guess percentage used maybe. Those are nice to haves, but we're not going to reject your data from the database if those are missing. Yep, blobs are binary large objects. So like if you wanted to store a media file or something like that, that would be, or another database. I don't know if you could actually do that, but probably. All right, let's talk about some other stuff. I'll get to the primary key in a minute. This is, what's AI again? Auto increment, we'll talk about that too. And then unique. So I think name should probably be unique, right? If we're talking about, well, maybe not. If we're talking about a specific crayon, we might have multiple boxes of crayons with the same, you know, there might be a cobalt blue in one box that is only 10% or that is 10% used. And then there's a cobalt blue from a different box that is less used. If we're trying to keep track of multiple crayons from multiple boxes, the name wouldn't be unique. So we know some of these things won't be not null, but none of them are unique. So here's a question actually related to this idea. Let's say we're trying to keep track of a bunch of different crayons from different boxes, and some of them might have the same names. How are we going to tell the difference between cobalt blue from box 1 versus cobalt blue from box 2? An ID, a box ID would be good too, and we'll talk about that in a little bit. But just an ID. So something that is critical to modeling data that we might not be used to is this idea of an ID or a primary key. So an ID is everything needs something called a primary key. It's a way we keep track of everything. We want to make sure that every single entry has a unique identifier. So we could check unique, we could check not null, but there's actually a box for primary key. And we can even check auto increment. So that'll allow this to, it's just going to automatically fill it in and increment it. So this is really nice. If we were only talking about the crayons in one single box and we knew that name was going to be unique too, we could also make unique. Why won't it look? Okay, I see why. We could also make name be a primary key as well. Primary keys also allow us to find things more easily. So if we know we're going to be searching by name a lot, it might be good for it to be a primary key. To answer the question of what's happening down here, this is SQL. So this is the actual SQL version. And the syntax is slightly different depending on what language you're using, but this is the actual SQL code that's going to create this table that we're also creating with this user interface up here. So there are more things we could do. We can create a default value, like we might say that the % used default is 0, because at the beginning, presumably, nothing has been used yet. So that's cool. If they don't enter that in, we'll just assume it hasn't been used yet. So the schemas are really important because, and they're one of the things that makes they're one of the things that makes a relational database really powerful. Is if you're working with something like, if you're working with Mongo or another document, things are more loosey-goosey. It's kind of like you're working with a JavaScript object. But it's really nice. One of the reasons I love relational databases is because I think that if you stick to this is how the data is going to look like, and there's a little bit of wiggle room, but mostly this is how the data is going to look like, and if it doesn't, we will reject it. It's a kind of a good start for actually writing good, consistent code. So what else do I want to talk about? Foreign keys are a thing. We will very briefly discuss those in a minute, but we will see those a lot more, I think, after the break. So before we move on, I want to say, or I want to ask you guys something. What is the difference between a schema and a table? Two important terms for working with relational databases that are kind of easy to mix up at the beginning. I love this. Schema is the setup information. It's the blueprint. It's the layout. Exactly. So the schema is something we decide at the beginning when we create the table. And it will inform what's allowed in the table and what's not. And then the table is just the place that we store the stuff. And yes, the table is where you eat your food. Cool. All right, so I am going to, let's see. I will give you a 5-minute break. Okay, I promised one of your PMs that I would not be answering any questions during the break today because I have a bad habit of doing that. So I'm going to catch up on any questions you guys have. And then I can't promise I won't talk about ridiculous things, though. I'm sorry if that's distracting from your breaking. So let me answer any questions you guys have right now, but then we'll take a break and there will be no questions during the break. So any questions before we step away? Oh, I see people typing. Uh-oh. Can I explain the real type? Sure. So integers are like whole numbers. So 1, 2, 3, 10, 20, 400. If you want decimals, you need real. So that will just allow you to do a floating point number. So any sort of decimal. Sure, I'll go over these boxes again. So not is not null. That just means it's required. So in this, I've made the name and the red, green, blue values required. Also, ID is, I didn't need to check it because by being a primary key, it is required. Primary key is something that just means basically it's unique and it's not null. So primary key is something that's going to be unique and not null. So we know it's a guaranteed identifier because every entry is going to have one and no two entries will have the same key. And then the next one is auto increment. That just means if you have some sort of number that you want to increment every time. U is unique. So like I said before, if we know that we just want one entry per crayon color or crayon name, we could check this so if I tried to put in 2 cobalt blues, the second one would be rejected from the database. So those are what all those things mean. And I actually had no idea that Alan Turing was the one who came up with floating numbers for computers, which I'm surprised because I know a lot of random Alan Turing things. Like, did you guys know that Alan Turing later in his life studied the patterns in nature? Like, why is a zebra patterned the way it is? And why are there so many crazy, beautiful patterns in nature? Except he didn't get famous for that because it's kind of much less important than the other stuff he did. That's my Alan Turing fact for today. All right. Okay, so now we're going to go on break, and I promise I won't answer any questions during break. Let me put up a 5-minute timer. And go. No, start. Actually, okay, I have to rant about Alan Turing though, which is that I know The Imitation Game is a good movie and it's probably mostly informative, but it was really annoying to me when I watched it because like there's all this drama in that movie that didn't really, and that's always what happens, right? Is they like dramatize it up. But I really enjoyed. I saw this quote from one of Alan Turing's like living relatives about how Keira Knightley is way, way, way more pretty than the woman that she actually portrayed. But yes, not to rag on The Imitation Game, but yeah, there was like they were like in the movie all trying to shut down his project, and it's like, oh, I don't think that really happened in real life. Yes, I know I said I wanted to answer questions, but yeah, all we need is the DB browser, and we won't need any other tools for the rest of class. All right. That's 5 minutes. So we defined this. No, that's not what we want. Where is, okay. So we defined this schema for crayons. Cool. Now, what if we wanted a schema for a box? So I'm actually going to put a few more minutes in this countdown and let you guys on your own come up with a schema for box. So there's no right way to do this. You know, you might come, you and we all are probably going to come up with pretty different ideas for this. But let me just give you, yeah, I'll give you 3 minutes to work on this, and then we'll come back together and talk about what you guys came up with. So a little chance to practice. As a reminder on how to do this, add a field whenever you need to add one. And if you, I wonder if I can pull up my schema for the other one so you guys can see. So like a crayon box. So it's like, what information might you want to, if you're trying to keep track of different boxes of crayons, what's some different information you might want to store about it? I am going to see if I can pull up that other schema so you can. Cool. There you go. And you guys can let me know if you need more time or less time. All right, I'm not seeing any disagrees, so let's stop the timer and go over it. Okay, so let me, where, cool, box. Okay, so what are some of the fields you guys came up with? Count, absolutely. Count, size, kind of the same thing. I think size makes more sense. Vendor, price. We might want to keep track of number of colors. Weight, interesting. Percent full. ID, yes. So ID is pretty important. So let's make this, what are the data types we want on this? Size, probably going to be an integer because it's just a count of how many Vendor is going to be text. Price, we'd probably want a real number so we could keep track of it. SKU, maybe, yeah. So which of these is our primary key? We know we need remember, a primary key is going to be a unique identifier. So it has to be not null and it has to be unique. And we can just do primary key and auto increment and it'll take care of this for us. So yeah, so that's a pretty good place to go. Now, one thing that's cool is that we could actually make we'll talk more about this after the break, but we could actually put a field in crayons called box ID so that we could keep track of which crayons go with which box. And that's one of the really cool things about relational databases is that we can actually use this ID system to say, this crayon came from this box. And then we could query and find all the crayons from box 1 or all the crayons from box 2. And that's what a foreign key is all about. So I don't want to sink too much time into that because it's a topic we're going to explore in a lot more detail later, but I wanted to put it on your radar for now. As far as Booleans go, a lot of the time, once again, I'm new to SQLite, so I don't know if it's SQLite or if it's just DB browser, but usually there is a Boolean field you could put in. I'm actually surprised to not see it in here. A blob, someone already posted a little, what does it stand for again? This is like binary something something. I always forget what that acronym is. If someone else wants to post it, it's essentially like raw data. Integer are whole numbers. I don't know the difference between numeric and real though. So if anyone wants to investigate that, be my guest. Cool, so we have created these two schemas. So that's like the setup stage. So now we want to enter stuff in. So the things that we put inside of tables are called records, or often they're just referred to as rows. So those are our entries. So now that we have this crayon thing, we can, let me see how to, I don't know how to actually insert stuff using this. I probably should have figured that out. Well, it seems to be up here. Can I just execute SQL? Well, I could try just writing some raw SQL, but I don't think we want to get into that yet. All right, I don't like this tool. So, sorry. I'm like, user interface. I just want to write SQL code. Browse data, is that how we do it? And then can we, ooh, new record, yes. Thank you, Stefan. Okay, so we go into browse data, we can pick our table, and we can create a new record. Sweet. So now we could call this, this is my favorite crayon color when I was a kid, Purple Mountain Majesty. I have no idea, what are, okay, cool. Not that it matters that much, but we got to be accurate, right? So red. Nice. And then % used. Obviously, a lot of this has been used since it's my favorite color. So maybe 65% used. Melting point. I don't know. What do you guys think? Like, oops. Why is melting point null? I'm not sure. I will wait. 202, probably. Well, I don't know why it won't. Was it something in the schema or? That's a real number. Oh, well, it's a mystery. I blame the interface. But you guys get the point. We can fill stuff in. And notice that I didn't need to fill the ID in. And if I create a new record, it goes ahead and auto increments that ID. So that if I had multiple Purple Mountain Majesties, I'd be good. Real numbers can't be null. So any field can have a null value in it, no matter the type, unless you say not null. The only thing preventing this from being null, I don't know why this is, there we go. I'm just bad at, I think I'm just bad at clicking. I wonder if different crayon colors do melt at different points. That's an arbitrary but interesting question. Yes, user error. It's always a user error. So anyways, we could keep entering in stuff here. And we would be, yeah. So I'm going to move on from this interface because I think we get the point, and let's get into the actual SQL. Yes, we should all, over Christmas break, we should all do a Zoom science experiment where we try to melt crayons. It'll be great. It'll be fun. I'm pretty sure I did a similar science experiment in the back of my mom's car when I was like 4 years old, because there was a pretty serious crayon melt crater back there. Ooh, we have some very official sounding information about the melting points of crayons. It would make sense that pigment would affect it since, you know, black attracts more sun and stuff like that. From Google, nice. Well, I'm glad we got that sorted out. Okay, so the last few things I want to mention before we get into some actual SQL is who does what. And this came up a little earlier. So coming up with the schema, actually figuring out which tables are going to be in our database and what the schema is for each, that is a DBA type task. That is, the database administrator will probably be doing that. And that's called data definition. Some other things are permissions. There are meta tables that'll keep track of users and roles and things like that. The database administrator will be figuring out who has permission to do what to which table. For example, you shouldn't be able to just delete a bunch of records probably without good reason. So, so these are tasks. The schema thing is really important to understand because you, the developer, if you're sending data that doesn't fit the schema, you're going to be in trouble. But you will probably, in the real world, not be actually defining the schemas. But what you will be doing is called data manipulation and data querying. And that's really what we're about to get into. So data querying is just viewing records. Data manipulation would be adding, updating, and deleting. So that's all CRUD stuff, right? Viewing, adding, updating, deleting. That's all what we've already done already on the API side. So that's really what we're concerned with as developers when it comes to the database. The schema, though, as I said, is still critically important to understand because you'll have a really hard time, especially inserting and updating records if you don't know what's required to be in the database. So we are about to move on to the actual writing of the SQL. Does anyone have any questions before we get on to that? Oh, wait, I see a question. What is the default SQLite sequence? I'm not quite sure where that's coming from. So sorry. There's a third table. Oh, SQLite sequence. Interesting. I mean, I don't know exactly what that is. I have no doubt that it's some sort of meta table that's helping keep track of what we're doing in here. But that's a good question. Another thing you could Google if you're feeling curious. Any other questions? Is there data in it? Let's find out. Crayon. Ooh, I wonder if it's helping keep track of, let's do a little experiment. Okay, it's keeping track of the auto incrementing. That is my theory. All right, I'm going to move on to this. So you will get to play with this in the homework tonight. Let me make sure this link actually will send you where you're supposed to. Yeah, looks good. So there's a link to this in the homework as well. I will I just posted in Slack, so if you guys want to query along with me, and in fact, you should open this because I'm going to invite you to query along with me. So now we're not so much interested in creating records. We are now in a existing database. So this is just a nice little mock database that W3 Schools makes available to us. We can already see that there are a bunch of tables already created, and we can query them to our own heart's content. And I just want to say right now that any plan that involves a flamethrower, I am on board, just automatically. I will regret, I feel like I will regret saying that. All right, cool. So, okay, so let's start with a basic select statement, which is what we have up here. So select statement really is the simplest thing you could do, the simplest query. So the pattern is select. This is a keyword in SQL. This star means all. So that's saying all of the fields. Select all the fields from, and then you have the name of your table and some brackets. And then you run the SQL and we get all the suppliers. I could change the table name. And now instead I am seeing all the employees. So pretty simple, but if you guys wanted to see all of the records from categories, what command would you do to see every single record inside of the categories table? Select all from categories, exactly. By the way, the capitalization is convention to capitalize SQL keywords, but not necessary. Still works. Okay, so the basic select gets boring really fast, but we can make it more interesting. What if I wanted to just see the first and last name? So I can replace the star with specific fields I'm interested in. And they will appear in the order I list them. So first name, last name. Let's go over to shipper, suppliers. If I wanted to see the supplier name and the city of all my suppliers, what would I do? If I wanted to see all this, but I'm really just interested in the name of the supplier and what city they're from. Nice, this is good. I don't even have to type. I can just steal commands from Slack. This is like my goal, is find the most lazy way to teach this class as possible. So, yep, so now I see supplier name or city. Here's a question. What if I wanted to see first the supplier name, then the city, and then all the other fields, but I don't care about the order? You can always list a few explicitly and then just throw the star in. So that's saying I want to see everything, but make sure this comes first and this comes second. So just a couple basic things we can do to make our selects a little more interesting. So that's the start of selecting, but things get really interesting when you put the wheres in. So maybe I really only care about suppliers from the UK. So, you know, right now I've been filtering by field. You know, I've been rearranging the order of the fields and in some cases only selecting a few fields. But what if I'm interested in filtering out different rows, different records? That's where where statements come in. So this is, we're now adding criteria. So I might say where country equals UK. Exotic liquid and specialty biscuits. What are up with these suppliers? It is the UK, I suppose. I shouldn't say that. I think Tom's watching. But so, okay. So these are all our suppliers from the UK. So now all of a sudden, now let's think about that example I gave at the very beginning of trying to do this in something like Excel. Now, instead of trying to search through and, you know, use the command find to find all the UK suppliers, with just one command, I have exactly what I need. So what if I wanted, let's see. What if I wanted all of the, I think I showed you something similar to this at the beginning. What if I wanted all of the products, ooh, here's one that's slightly different. What if I wanted all of the products whose price was less than $20? If we write UK lowercase, will it still find it? I don't believe it will, but we can experiment with that. So yeah, it's going to match because it's a actual, because it's an actual string or a bit of text, we need to match it exactly. Well, we don't have to match it exactly. We'll talk in a minute about tools we can use to not match exactly. But first, let's find all of the products in the product catalog whose price is less than $20. Perfect. So we saw something with an equal sign, but we can use less than or equal to. We can use less thans, we can use greater thans. Sweet, so now I can see everything. That's a lot. Let's lower our cap. Let's do 15. Here is a question. What if we wanted to see these, but we wanted to actually put them in order? So we not only want to see everything whose price is less than 15, but we'd like to order them by price as well. We can do that too. It turns out there is an order by as well, so we can do order by price. Yep, and we can, as already mentioned, throw this little descending keyword in if we wanted the price to be from greatest to least. And with the order by, we can actually do multiple criterias. Let's say we're interested in price, but first and foremost, but then secondly, we're interested in product name. So notice that all of the $14 items are now ordered alphabetically by product name. And if you guys are panicking and being like, oh, how am I going to memorize all this? You don't have to memorize all this. The point of what we're doing right now is to get you familiar with some of the things you might be able to do using SQL. As far as learning and memorizing the syntax, to start, you'll probably just have to Google search and look for references, and then pretty quickly you'll just commit it to memory. So the last thing I want you to do right now is try and cram your brain with this stuff, because there's lots of references you'll be able to find online. I want you to just start to get an intuitive sense of what kind of things you can do with SQL. So let's get rid of this order by for a minute and talk about some other wheres. So we can do multiple where criterias. So we might say where price is less than 15, and let's say we want only things from category 3. Category ID equals 3. So I think category 3 is either baked goods or something or this or that. Let's go over to categories for a minute. Excuse me. Okay, so 3 was confections. So if we wanted to find all the, poisons. I might have entered this in previously. You guys will not find poisons in your database. This is what I do with databases when I probably should have reset it, but now you guys know what I've been up to. First the flamethrowers, now the poisons. So let's say we wanted to find all of the seafood. If we wanted to find all of the seafood in our product list, how would we find that? What query could we use to find all the seafood? Yes, we don't like where poison and seafood overlaps. I will give you a hint. We do have to go back to products to get this. Perfect. So select all from products where category ID equals 8. So we can't search by, what I'm about to say is both true and not true. We can't search by category name because there is no category name in here, just ID. However, it turns out that we can. We won't be learning this today. This is a little glimpse into the future. This is one of the things that makes relational databases really cool, is even though this table doesn't have a category name, we can actually join together this and the categories table by ID, and then without even having to know which ID seafood is, we could actually construct a query that finds that for us. So we won't be doing that today. That's a little more advanced, but just to let you know, that's where things get really interesting, is we could be, we could say, okay, I want all the products whose price is in this range from the supplier alphabetized. It can start to get really complex as we put it all together. So let's say we wanted a couple different products, categories. So let's do seafood and meat and poultry. So that's 6 and 8. So we could always do where category ID that would be or. It's not possible for it to be both 8 and 6. But this is a little clunky. There's actually a shorthand for this. Yep, and we already see it, which is in. So if there are a couple different, if you're interested in one field, but you want to make sure that things are from, you have a couple options from one field, you might say category ID is in. So all that means is I want everything from products where the category ID is on the list. That's how in works. It's in the in group. All right, the last thing I want to show you with selects, I'll show you a couple more things. So the next thing I want to show you is wildcards. So sometimes you don't know exactly what you're looking for. So let's say that we trying to find one that will come up with something interesting. I'm not gonna waste my time with this. Okay, so we're looking for a customer, and we know that, or we're looking for a contact, and we know that the contact's last name is Mendel, but we can't remember the full name. So if we just did from customers where contact name equals, we get no results because no one's contact name is exactly Mendel. But we can use this percent sign. So this is saying, I don't care what comes before this. I just know I want it to end with Mendel. Oh, I thought I picked one that was actually on the list. Oh, sorry. We need the like operator. So instead of equal, we say like. And like means I have some idea of what I'm looking for, but not precise. Sweet. So then we were able to say Mendel. But maybe instead we remembered, okay, I remember the first or last name is Roland, but I can't remember which is which. We can just say something that has Roland anywhere in the contact name, which is still just this. But notice that if I make this more vague, now everyone who has AN in their name pops up. So in that way, we can match things partially. That postal code might be actually a really good example of when we might use this. We're interested in all the 80 postal codes. So we might say where postal code is like 80 whatever. We're saying it needs to start with an 80, but whatever comes after that is fair game. And we see that there's one in Austria, one in Germany. All right, anyone have any questions so far? Queries you want to see me make? Don't give me something too hard. It's late. Any questions on this before we move on? And honestly, we're really close to the end of the lesson. There are a couple more things I want to show you guys, but we're probably going to get out a little early tonight for once. Can't promise it'll ever happen again, though. Count, yes, count is actually one I was going to talk about in just a moment. So, all right, I guess that's my cue. So, let's say we want to know how many orders are in here. I mean, we know it's 196 because it says that. We can actually use an operator called count, though. So that's just saying, okay. So it's not too interesting if you just do a regular count without a where. All that will tell you. I mean, it's a nifty little shorthand to figure out how many entries you have in your database. But let me get rid of count for a second. Let's say that we are interested in how many orders we have for a few different employees. So we might say, actually, I'll ask you guys this. We want to know how many orders have been placed with employee ID number 5. Who is that? Good old Stephen Buchanan. So employee number 5. We want to know how many orders have been processed by Steve, whose ID is 5. So how can we use count and some other tools that we've already learned to figure out how many orders Steve has placed? Awesome. So we need that count operator back. And then we can use a where statement to say where employee ID equals 5. And we see that there have been 11. What if instead we're not just interested in Stephen, but also in Laura? So we want to know how how many orders have been placed by either Laura or Stephen. So employee number 5 or 8. How could we alter this so that we can count how many orders have been placed by either employee 5 or employee 8? Yep, so we could use an or, but the better thing to use would be an in. So whoever's in the list, so it turns out there's 38. If we wanted to get really crazy, we could actually rank our employees by how many orders they've placed. But that would be, once again, a little more advanced. But just that's the kind of thing we can do with not too much work in SQL. So let's talk about distinct. So let's go to how do we, what's the best way to do this? Let me try this. Distinct. Those are already distinct, but I'm trying to think of a good real life use case for distinct, but I'm not sure it really. Yeah, we could do, let's try this. There we go. Is this customers? Yes. Okay, what is this going to do? Do you guys have any guesses about what this SQL command is going to do when I run it? Only those that appear once? Not quite. It's going to just select one of, so if let's actually start by getting rid of distinct. So if I say select country from customers, see I have a bunch of, if I'm just looking at the countries, I have Mexico in there multiple times, I have France in there a bunch, but if I'm just interested in a list of the countries, it's not really helpful for me to have multiple copies of these. I want to get rid of the duplicates. So that is what distinct will do. It'll give me a list of all the countries that my customers are from, but with each just listed once. Yep, so it doesn't delete them. So these select statements, they're not altering anything. They're changing what we see or what we get back, but nothing's actually being deleted or altered. It's just changing what we see. It's a great question. And we could even throw a count on top of this. If we're curious how many distinct countries, we're like, hey, how many countries do you think we have customers from? All we need is a count and a distinct, and then we would find out that we have 21 different countries. Another thing I saw someone mention is, what if we want to see, like, let's go back to products. We were talking about ordering these, right? So if we want to see the cheapest products, we could do order by price. But what if I'm only interested in the 5 cheapest products? I could always do limit 5. And so that's a way of saying I'd only like to see 5. So if you don't do any sort of ordering, you'll often see ordering and limiting together. If you don't do it, you'll just see the top ones, but ordering and limiting tend to go nicely hand in hand because you're actually, the limit is a little more meaningful if you put it in order. Total cost of the price. I'm not sure, like what is the sum of all the prices of all the items? The sum, okay. Yeah, there's a sum operator. So we could do select sum price from, what is this called, products? Do we always need brackets? No, we don't actually need brackets. It's nice. It's kind of like capitals. It's really nice because it's very clear what the table name is, but you don't need them. All right, so I want to show you guys an insert and an update super quick. I'm not going to spend much time on it. There's, I think, a few questions on the homework about those, but you can look at documentation. But I just want to go over them super quick first. So if we want to insert something in a table, for example, you know, we don't have any poisons right now. That's category ID. So if we do select all from products, was it 9? Or category ID equals 9, nothing. So maybe we want to put a poison into the products table. So we could do insert into, that's how you start it. And then we need the name of the table. So we can do into products. And then we want to list what fields. Let me actually remember what's even in our products. So maybe we want to do product name, supplier ID, category, unit, and price. Let's just fill everything in. So we can put in, and as long as these aren't required, we don't have to fill in every single one on here. And then we have to say the values. So we use the values keyword, and then we have to put all the values we actually want to put in. So we can say product name is Hemlock, supplier, supplier number 3, 2, sure. You know it's category 9, unit is 1 vial. Let's say a 6-ounce vial. Poisons always come in vials. And the price is a little pricey. All right, let's see if that works. Uh-oh. Oh, produce name. That's not going to work. Product. Cool. So it says I have made a change to the database. Yep, I've just lost all you guys' potential coffee shop customers because you know about my vials of hemlock. All right, so if we wanted to confirm that our hemlock had made it into the products database, how could we look for it? How could we confirm that our vial of hemlock had made it into the products catalog? As to the question of what is going on in Bisbee, no one will be able to truly answer that. We have a pirate weekend. That's all I need to say about Bisbee. And the pirate weekend it's just basically a bunch of drunk people dressed as pirates run around for like 2 days. But enough about pirates. How do we find our poison in the products? All right, I see one person has their mind off of. Yep, so we could check the table and scroll through. A very quick way to find it would be to look for it specifically. We could look for it by category ID. We know it's the only one in the category. And there it is. So we have successfully entered our hemlock into here. I better restore the database when we're done here before the government comes for me. And the final thing is if we wanted to update, if we're like, oh, oops, actually, the price of hemlock is going up. So let's say we need to update products, set price equal to price of hemlock went way up. And we can do multiple of these. If we also wanted to say, oh, the price went up, but it's because the unit, we're actually now getting 8-ounce vials, you could do that as well. Oops. You need where statements for updates. This is good. I'm glad I did this. This is not what I meant to do. So because there's no where in here, I actually updated every single product with this. So what I wanted to do is something like where product ID equals 78. But because I left out that where, let's select all from products. So now everything comes in an 8-ounce vial and is $27. Yep, it's like, yeah, the $27 store. Yes, so where is important. So like I said, I don't want to spend too much time on inserts and updates. We'll talk more about them on Thursday. And for the little bit you need to do with them in the homework, yeah, I think you can use documentation to figure them out. Just learn from my $27 store mistake and make sure that. Now I'm just going to spend the next like 10 minutes being like, an 8-ounce vial of tofu, an 8-ounce tile of, what are all these products? Some weird stuff on here. I hate it when my Scottish long breads come in an 8-ounce vial. Yeah, and this is also, as is being said, this is a very good reason why you should always back up your database. I like this PSA about why you should use where. All right, enough of that. Any final questions? I will go over the homework real quick and then we'll talk about final questions. So homework for tonight is pretty straightforward. There's, it's just kind of tinkering around and practicing this stuff. So you're gonna be encouraged to basically do what we've been doing. Use these tools and this actually exact same database to do some querying and then do a little bit of updating and adding at the end. We also want to kind of out of order. So the second thing is you'll be playing with DB browser, creating, here's a couple, or I think just one schema that they want you to create. And then a couple stretch problems, which are pretty fun. So honestly, the homework pretty straightforward, just getting comfortable with it. I would spend some time tinkering around, make sure you're feeling really good about this stuff because it is about to get more complicated. So that's it for tonight. I'll answer any extra questions we have in a minute. Then you guys are free to work on this. And on Thursday, we will talk about actually applying this into our servers and plugging this into the JavaScript side of things. Any more questions? Are we submitting the DB browser part of the homework? Ooh, that is an excellent question. There is nothing about that on here. I don't see anything about that, but I would maybe reach out to your PM to get confirmation on that. If they don't know anything about it either, then I think you're probably good to go. But I unfortunately do not know the answer to that question. Okay, sounds like you are submitting that as part of your homework. I'm so glad that you guys know more about what's going on in this class than I do. It's really convenient for me. All right, any other questions? I know I said we'd probably get done early and it's not really that early. I think you guys just want to get done and get working on this. Okay, well, that is it for tonight. I will see you guys on Thursday for part 2 of databases and database persistence. Have fun with the homework, and I'll see you guys then. Watch out for 6-ounce vials of poison also. I hear they're afoot these days. The name of the coffee shop it's just called Liquid Death Coffee. No, it's not called that. All right. Bye, guys. I will see you on Thursday.